By Jonathan Amos, BBC Science correspondent, New Orleans. Media playback is unsupported on your device. Media caption: Scientists think HTHH might hold clues on where to look for life on Mars. It is one of Earth's newest landforms and it could just tell us where to look for evidence of life on Mars. The tongue-twisting volcanic island of Hunga Tonga Hunga Hapai exploded out of the Pacific Ocean in 2015, and its shape has been evolving ever since as it has been lashed and bashed by waves. Scientists are watching this slow erosion very closely. They think they see the remnants of many such water-birthed islands on the Red Planet. If that is true, it is really intriguing. On Earth, we know that wherever you get submarine volcanic processes, you also very often get conditions that support microbial communities. What the researchers see occurring at Hunga Tonga Hunga Hapai HTHH therefore may be a kind of template to help them understand better the water environment on early Mars and, by extension, whether the conditions might also have been favorable for the initiation of simple life. Image copyright NASA JPLU. Arizona image caption Martian version. Scientists think they see fields of tough cones on the Red Planet. Media playback is unsupported on your device. Media caption Dr. Jim Garvin: We're watching the island do its dance. The thought was that we might be able to use recognition of these kinds of landforms to be an indication of paleo-water stories, depths and longevities on the Red Planet, said Dr. Jim Garvin, chief scientist at the U.S. Space Agency's NASA Goddard Space Flight Center. So, we're going to use HTHH on Earth to train us to understand Mars. Dr. Garvin and colleagues have been reporting their studies of HTHH here at the fall meeting of the American Geophysical Union (AGU), the world's largest annual gathering of Earth and planetary scientists. The island grew out of the Hunga volcano, a 1.3 km high mountain that is all but submerged in the southwest Pacific in amongst the Tonga archipelago. Baby Island in the Pacific. Image caption: The French Pleiades satellite pictured the area before and after the eruption in 2015. HTHH is the name used by scientists to refer to the 200-hectare landmass it emerged between the existing Hunga Tonga and Hunga Hapai islands. All three landforms sit atop a 1.5 km tall submarine volcano. Inset depth map. Erosional models suggest HTHH could last from 6 to perhaps 30 years. Image caption: Satellite-derived elevations showing the island in April 2015 and September 2017. The new landform came into view in what is termed a Surtsean eruption, named after a very similar island called Surtsey in the North Atlantic, off Iceland, in 19637. In such events, hot magma coming into contact with cold seawater causes a violent blast of ash and rock fragments. This material then collects at the ocean surface, forming a tough cone that in HTHH's case is more than 100 meters high. But scientists do not expect it to stick around forever. Storm action should eventually dismantle it. Image copyright NASA copyright 2017 Digital Globe. Image caption: A perspective view from September 2017. The brown overlay shows material lost to erosion. However, this could take several decades and scientists intend to use high-resolution satellite imagery to watch the process every step of the way. Indeed, this is the first such island in the modern space era to erupt like this and not immediately disappear, giving scientists an unprecedented view from orbit of HTHH's early life and evolution. One of the things we're hoping to do with HTHH is connect the pace of erosion with water at different depths, Dr. Garvin told BBC News. We'll end up with time-lapse photography of this island going through its erosional cycle, and that will give us then a sequence to go look for on Mars. If we see it there, then maybe that tells us that water on the planet in some of these places was tens to hundreds of meters deep, and present long enough certainly to do the same erosional work. Image copyright GPORBASSANO. Image caption: French sailors visited the island to collect rock and ash samples for scientists to analyze. Water and time are essential ingredients for life. So too are an energy source and a supply of nutrients. On Earth, all these conditions are found at volcanic vents on the ocean floor. Microbial communities build up around the mineral-rich waters that gush from in hot rock. And this is one of the reasons why scientists are tasking satellites now to look for evidence of similar, past activity on the Red Planet. Mars is currently bone dry, but it was not always that way, and if it had volcanic systems similar to HTHH or Surtsey, then the remains could well be among the best places to send a rover to search for signs of preserved biology. Dr. Garvin said hydrothermal systems on Mars have long been realized as being a great spot both for possibly having had life or producing minerals and landforms that could preserve it. We talk about biosignature preservation potential. It's one of the things the Mars 2020 rover that NASA is flying will go look for. His colleague Dr. Dan Slayback has been trying to work out how long exactly HTHH might be with us. The satellite imagery observed very rapid decay early on. If the trend had continued, we would have expected perhaps a 6-year lifetime, but at about the 6-month mark, the rate of change decreased, the Goddard scientist told the AGU meeting. A simple linear fit to all of our data today gives us a 2,630-year lifetime. Media playback is unsupported on your device. Media caption footage from the January 2015 eruption. Jonathan Amos, internet at bbc.co.uk, and follow me on Twitter at bbcamos.